How does a hydraulic system work, and what are the basic components in a hydraulic circuit? To answer these questions, this video introduces the concept of a hydraulic circuit and takes a closer look at the basic hydraulic components of a forklift truck as it lifts and lowers a heavy load. Nearly all material handling and earth-moving machines operate on the principles of hydraulics, rather than simple mechanical systems. A hydraulic system uses pressurized liquid to transmit power and perform work. Let's take a closer look at the main components of a hydraulic system and how they operate. The hydraulic tank, or reservoir, is where a sufficient quantity of hydraulic oil is stored for use in the hydraulic system. Some hydraulic cylinders, such as the lift cylinders on high-reach forklift trucks, can extend 10 meters or more to reach the highest shelves in warehouses with high pallet racking systems. As oil flows into the cylinder, the jack extends and the cylinder fills with oil. As a result, the oil level in the hydraulic tank can drop significantly. For this reason, the size and oil capacity of the hydraulic tank must be designed with all cylinders fully extended in mind. The oil level is checked using a dipstick when all cylinders are fully retracted. The reservoir is not pressurized. It is vented to the atmosphere through a small filter element known as an air breather, which is usually located inside the filler cap. This ensures that constant atmospheric pressure is maintained above the oil surface. To keep hydraulic components operating correctly, the oil must be kept as clean as possible. Contamination and tiny metal particles produced by normal wear and tear are removed from the system by filters. However, a fine mesh filter cannot be used in the pump suction line, as it would restrict oil flow, making it difficult for the pump to draw in oil and causing a pressure drop. Instead, a coarse mesh strainer is used. To improve its ability to capture foreign particles, the strainer is often made from magnetic material. The pump inlet line is not a rigid steel pipe. It is a low-pressure rubber hose designed to absorb vibration. It is essential to ensure that no air is drawn into the pump through this hose, as this can lead to harmful effects, such as cavitation and aeration. The next essential component of a hydraulic system is the hydraulic pump. It is the heart of the hydraulic system. The pump has an inlet or suction port, which is normally larger than the outlet port. This allows the hydraulic fluid to be drawn in more easily, without a pressure drop. One of the pump gears, called the driving gear, is connected to the engine power takeoff and is driven by the engine. The other gear, the driven gear, is rotated by the driving gear. The gears rotate inside a tightly fitted housing in the opposite directions. When the teeth of the gears separate at the bottom, the resulting vacuum draws oil into the pump. The oil is trapped between the gear teeth and the housing and is carried around the outside of the gears through two separate paths. As the gear teeth mesh again at the top, the oil is forced out through the outlet port under pressure. The faster the engine runs, the greater the oil flows. This is why, by pressing the accelerator pedal harder, the operator can lift the load faster when the transmission is in neutral. The pressurized oil delivered by the pump is used to operate the hydraulic cylinders. It flows through steel pipes, flexible hoses, and hydraulic fittings. The pressure, flow rate, and direction of the oil are controlled by a number of hydraulic control valves, which are usually combined into a single valve block, known as the combination valve. The direction of oil flow is controlled by the directional control valve. This valve contains a sliding spool that moves back and forth in response to the operator's commands. When the forklift's control lever is in neutral, hydraulic oil does not flow to the cylinders and instead returns directly to the tank. This type of setup is called an open-center hydraulic system. A more advanced version, the closed-center hydraulic system, will be covered in another video. Advanced hydraulic circuit. When the operator pulls the lift control lever backward to raise a load, the sliding spool in the valve moves, connecting the pump port to the bottom port of the lift cylinder and the top port of the cylinder to the reservoir. This allows hydraulic pressure to push the piston inside the cylinder upward. The motion of the piston is transferred to the forks via a chain and roller mechanism, thus lifting the load. Notice that blue color represents low pressure, also known as tank or terrain pressure. Green represents high pressure, also called load pressure, which varies depending on the weight of the load. The hydraulic cylinder is a linear actuator. Another type used in some hydraulic or transmission systems is the rotary actuator, also called a hydraulic motor, which produces rotational motion instead of linear motion. As you may have noticed, oil can continue to flow toward the bottom of the cylinder. If the operator holds the lever even after the cylinder reaches the end of its stroke, the pressure will rise rapidly, which can damage components or burst hoses. To prevent this, a pressure control valve, in this case the all-important main relief valve, opens to let the pressurized oil return to the tank. The pressure at which the main relief valve opens is called the relief pressure, and it is set based on the machine's rated capacity. In diagrams, this is often shown in red. The piston inside the relief valve is held on its seat by a spring. The spring force can be adjusted with an adjusting screw, which changes the system's relief pressure. This is a simple but very sensitive procedure. It's important to note, when a hydraulic system seems to lack power, low pressure here is rarely the cause. Increasing the main relief pressure by turning the adjusting screw should be a last resort and is generally not recommended. To lower the load or the forks, the operator pushes the lift lever forward. The sliding spool inside the valve moves again, this time connecting the top port of the pump to the top port of the lift cylinder, and the bottom port of the cylinder to the tank. However, in this case, the piston could descend too quickly, because the weight of the load adds to the oil pressure on top of the cylinder. To control the lowering speed, a third type of valve, a flow control valve, is used. This valve consists of a check valve and a restriction or throttle valve. The check valve, also called a one-way or non-return valve, allows oil to flow freely in the lifting direction but blocks flow in the lowering direction. During lowering the load, the oil is forced through the narrowed passage, orifice, or throttle, which slows the flow and limits the speed of the piston. The relationship between oil velocity, pressure, and orifice cross-sectional area is described by Bernoulli's principle. It's important to note that pushing the control lever further or revving the pump increases the flow, which speeds up the lowering. If the operator keeps holding the lever forward and the high-pressure oil exceeds the relief valve's set pressure. The valve will open, pushing the oil back to the reservoir and protecting the system. A return line filter, a fine meshed paper element, can now be installed in the drain line to completely remove contamination and tiny metal particles from the hydraulic oil. Hydraulic oil and filters are changed during preventive maintenance, typically every 3,000 hours. Only manufacturer-recommended oil and filters should be used, and the oil viscosity should match the ambient temperature in which the machine operates. There are many other valves and control devices in a real hydraulic system to ensure safe, smooth, and efficient operation. Please subscribe to my channel, K1 Engineering Studio, to receive my other videos on advanced hydraulics, basic transmissions, diesel engines, mechatronics, and more. For this basic hydraulic system animation, however, we will discuss only 2 additional valves that are commonly used in hydraulic circuits. 1. Load check valve. The load check valve is a non-return valve that allows oil to flow only from the pump to the actuator. Its main function is to prevent the load from drifting downward due to the internal leakage inside the valve block or a pressure drop in the pump line. For example, when the control spool moves from the hold position to the lift position, it may take a short time for pump pressure to build up and exceed the load pressure. During this brief period, the piston may drift downward before starting to move upward. This situation typically occurs when the load check valve is faulty and stuck open, allowing reverse oil flow. When functioning correctly, the load check valve blocks the line until the pump pressure reaches and overcomes the load pressure. Two. Safety suction valve. This pair of valves works together to relieve both positive and negative pressure in hydraulic lines that are not connected to the reservoir during sudden external impacts. As shown here, the cylinder is in the hold position, and the spool has blocked the circuit. There is no connection between the cylinder lines and the reservoir or the main relief valve. Now imagine a heavy object suddenly falls and strikes the cylinder rod or the load while the system is in this position. A dangerously high pressure can be generated on one side of the cylinder with no path to release to the tank. At the same time, a vacuum or negative pressure may form on the opposite side. Both conditions are harmful and can cause permanent damage to hydraulic pipes, fittings, and components. To prevent this, a secondary pressure relief valve, called the safety valve, is used. It automatically opens to release excessive pressure to the tank. On the opposite side, a check valve, the suction valve, opens due to the vacuum, allowing oil to be drawn from the reservoir into the cylinder. This concludes my basic hydraulic system video. Although we examined only a simple circuit, you should now have a clear understanding of the general principles of hydraulic systems. I will soon upload more advanced videos covering advanced hydraulics, basic transmissions, diesel engines, basic electricity, mechatronics, and more. Please support my channel by liking the video and subscribing. Thank you for watching.